Hello and good afternoon, everyone. Today, I have today our group have do the stability of floating body in this report for the experiment. Now, first all, my lecturer is Dr. Muhammad Arif bin Fazali and our member Hafiz Nurizuddin bin Iman, that's me, co-veteran, anak lelaki Rajendran, Guru Afifah binti Zulkifli, and Siti Aisyah binti Muhammad Isyam. So, for the experiment is designed to demonstrate the stability of floating and cylinder and to familiarize the student with the concept of buoyancy, metacenter, and metacentric head. So, the center of the buoyancy, the C for the symbol, the center of the display volume of fluid of a floating body depend on the shape of the body and on the position in which it is floating. So in the experiment, the head of vertical weight is adjusted to the new weight, while the x and degree value are to be recorded by putting the proton and pillar with horizontal and vertical weight into the water tank. Then distance between body center of gravity to center of matter Gm will be calculated to show the stability of the floating body. So the largest metacentric head implies greater stability. So this is the diagram for the hour experiment. So use a parameter to measure the stability of floating body quantitatively. So this the so this the diagram for our experiment. Gf is the guided measure of the stability of floating body due to coupling moment produced is directly proportional to the head of metacenter. So, in this experiment, we have three objectives that is study the equilibrium condition, stable, unstable, and neutral of a floating body, determine the metacentric Hm of the floating body, which is a critical factor in its stability, and lastly, analyze the effect of varying load and tilt on the floating body stability. So, for this scope of this experiment, the practical understanding of stability, gaining insight into principle of buoyancy, center of gravity G, center buoyancy B, and metacenter M. For the engineering application, applying the knowledge, the design stable floating structure such as ship, boat, and floating platform, creating stability behavior. Evaluate how alteration in weight, distribution, shape, and loading affect stability to ensure safety in maritime operation.
Theory and working principle. The buoyancy principle and the matter center principle control the stability of floating bodies. The submerged or floating object in the fluid receives an upward buoyance force equal to the weight of the fluid it displaces, according to the principle of buoyance. The buoyant force act through the center of buoyancy which is the centroid of the displaced volume of fluid. The stability of a floating body, however, is the main concern of the meta-center principle. It says that where the meta-center in the relation to the center of gravity determines how stable a floating body is. The meta-center in the point of intersection of the vertical line passing through the center of buoyancy with the line of action of the weight force. The center of buoyancy shifts to a new location (BO) as shown below as a result of several variables including and movement, which can cause a body to tilt. The intersection of the body's axis and the buoyant force line of action is known as the metacenter of point N, or tilt moment Rm to produce the weight W, and the buoyant force are combined to place the metacenter above the center of gravity. The body returns to the natural position at the righting moment, graduating stably. In contrast, the body becomes unstable if the metacenter is below the center of gravity cause of the overturning moment produced by the weight and the buoyant force. A body is demanding very stable or closely when its metacenter and center of gravity line up, suggesting a precisely balance between stability and instability. The metacenter height is mg. Okay. The G is gravity, the center of gravity. The BO is center of Lyons in natural position, and the B is center of Lyons of tilt shift. So when the ship is moved, the center of gravity also will be moved, as you can see at the second tilt shift. So the movement of the middle will be take as the theta, the theta, how many theta is increased. Okay, as you can see to the equation, OG equals to mg sine theta, and mg is equals to IOV, where the OG is center of gravity, mg is meta center of gravity, theta is tilt of ions, I is inertia, and V is the volume.
So, okay, hello. So for this experiment, this the apparatus that we use in this experiment. So first we have the water filled in the tank, which filled in with water, and vertical weight, the y-axis, and treat, and horizontal weight for the x-axis, pontoon stabilizer, and pontoon. So this methodology for the experiments. First, we have to fill the water tank to predetermined level, and second, place the floating body in the water and allow it to stabilize. Record the position of the body at equilibrium without any tilting. Gradually apply small weight to one side of the floating body to induce a tilt. Measure the angle of tilt using the inclination measurement device. For each applied weight, record the corresponding tilt angle and displacement of the center of buoyancy. Use the measurement to calculate the vector center Hm using the formula. After tilting the body, note whether it returned to its initial position, stable equilibrium, or continues to tilt further unstable equilibrium. Adjust the position of the weight to change the center of the gravity and observe its effect on the body stability. Perform the experiment with varying weight distribution and record the result for each case. And this is the formula that we use in the experiment. Gm equal to W times D over V, angle of tilt. So W is a weight of applied to get the tilt in Newton, and D horizontal distance from the center line to the weight in meter, and degree and delta is angle of tilt in radian.
Next, this is our result for this experiment on top, middle, and bottom. And the weight of horizontal weight is 0.294 kilogram, and the pontoon weight is 1.24 kilogram. For this question, we need to plot the graph of Gm versus theta and determine the value of Gm from the plotted graph when theta equal to 0, and then calculate the value of Gm for each test using an area of second moment. Compare and discuss the obtained value with the value of Gm from 1. Discuss the reliance of the metacenter on the position of the center of gravity in terms of stability of floating body, and then discuss the effect of variation in angles of tilt on the position metacenter. So next, this is the graph for the stability of floating body for test 1, which is the on top of the pontoon. And then this is the graph for the stability of floating body for test 2, which is in the middle of the pontoon. Next, this is the graph for the stability of floating body for test 3 at the bottom of the pontoon. Next, this is comparison between graph 1, graph 2, and graph 3. From the plotted graph, we can conclude that when we lower the position of the vertical weight, then the value of the metacentral height will be higher.
For discussion, first calculate the value of Gm for each test using an area of second moment. Compare and discuss the obtained value with the value of Gm for 1. The table shows of comparison of theoretical and experiment value of height of metacenter Gm. Next, discuss the reliance of metacenter on the position of the center gravity in terms of stability of floating body. Metacenter height, which is Gm, as a stability indicator. Stability improve with higher Gm. Calculate as Gm equal to Bm minus Bg. Bg is the vertical distance from the center of buoyancy to the center of gravity. In test 3, we know that the highest Gm result in minimal tide, indicating superior stability. In test 1, a lower Gm lead to a greater tide angle, showing reduced stability. Second, effect of center gravity, which is Cg positions. Lowering Cg reduce Bg, increasing Gm, and and enhancing stability. In test 3, with a lower CG, the ponton showed the smallest state angle. Conversely, raising the CG reduced GM, where increasing tide occur due to decreasing stability. Lastly, influence of horizontal weight shift. Shift Shifting weight horizontal affect the location of CG and alter VG. A weight shift increasing the distance from the center effectively lower CG, improving GM and stability. However, in test 1, a horizontal shift with a higher CG implied that by further reducing GM, confirming GM equal to I over V minus VG. Positive GM ensure the ponton resists overturning force. Discuss the effect of variation in angle of tilt on the position of the metacenter. In floating body experiment, variation in the tilt angle significantly impact the position of the metacenter (GM), a key factor in determining stability. As the bottom type, the center buoyancy, the point where the buoyant force acts, shift laterally toward the tight side. This shift causes the metacenter to move as well as it defined as the intersection of the vertical line through the new center of buoyancy and the initial vertical axis of the body. For small tail angle, the metacenter remains relatively stable and above the center of gravity, ensuring a positive metacenter height and stable equilibrium. However, of, as the tail angle increases, the movement of the center of buoyancy becomes more pronounced, and the metacenter may shift closer to CG. If the metacenter drops below the CG, the metacenter height becomes negative, leading to unstable equilibrium, increasing the overturning.
So, for safety and procedure in the experiment is wear a lab coat and closed shoes when doing experiment to avoid any accident in lab. Hair in a neat condition for male and non-Muslim students to avoid injury. When the measurement, take the measurement reading in your eyes perpendicular to minimize parallel error.
For the conclusion, the purpose of the experiment was fulfilled as the height of metacenter was determined by using the 3D method. Based on graph of the metacenter height, GM of all tested three tests in the experiment, the value of the GM of test 1, test 2, test 3 are respectively. According to the experiment, finding as the angle of tilt increase and metacenter height decrease with the increase in the height of center of gravity cause the decrease in the stability of floating body. However, how the value of the metacenter height is slightly different with the theoretical value. The difference of meta height may due to several problems that occur during the experiment, such as parallax error and Gini factor. From this experiment, we can conclude that the most stable position of floating body is the meta height is above the center of gravity and the angle of tilt supposed to be small.